Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In my weekly sessions on ISI CMI, I have taken many topics, subtopics, and also I have solved some previous year papers. Today I will be solving ISI 2018 Part B. This is in continuation to my previous session where I solved ISI 2018 Part A. So in this part B, we are having 8 subjective questions. They are supposed to be difficult, but in this paper, I feel this was not that difficult. We will see questions one by one. I'll be giving you analysis also for every question. So let us start solving from this question number 1. So we are given find all pairs x comma y with xy real satisfying this equation. Now, I have two methods to do this. First is that we can do this by graph also, but before that I will tell you without graph. Please see how it can be done. This first equation, I think it immediately tells us that x plus y upon 2 has to be equal to n pi, integer multiple of pi, which means x plus y will become equal to 2n pi. That means even multiple of pi. So this is my one equation. Now, this given equation here, you know how mod is open. So there will be 4 scenarios that x positive, y positive. In that case, this will become x plus y is equal to 1. But as you know, x plus y is equal to 2n pi. So by putting any integral value of n, we cannot get x plus y is equal to 1. So not possible for this case because x plus y is equal to 1 cannot be obtained by taking any n belongs to integer. It has to be either 0 or it will be 2 pi or minus 2 pi like this. So this is not possible if we combine this with this equation. Similarly, if x and y both are negative, then mod x will be minus x, mod y will be minus y is equal to 1. In this case, x plus y will become equal to 1 minus 1. This also doesn't seem to be possible because x plus y has to be even multiple of pi, whereas this is minus 1. So this is also not possible when x and y both are negative. Now, I will be taking x positive and y negative. If that is the scenario, then we will get x minus y equal to 1. Let me call this as equation number 2. If we simplify, if we solve 1 and 2, we will be getting x is equal to n pi plus half and y will be n pi minus half. Now, we want x to be positive and y to be negative. So, only possible value for n is 0 here. Why? Because if you take n is equal to 1, if n is equal to 1, 2 and so on, then both x, y becomes positive. You can check it here. Similarly, if n is equal to minus 1, minus 2 and so on, then also x, y both becomes negative. So the only possibility is n is equal to 0. We have already negated this possibility. So n is equal to 0 will give us x is equal to half and y equal to minus half. So that is the solution of this one solution of this question. Now there is one more possibility where we may have x negative, y positive. In this case, we will get minus x plus y is equal to 1. Let me call this as equation number 3. Then solving 1 and 3 together, we will be getting, I will skip this portion where n has to be 0, or let me do it quickly. We will get x is equal to n pi minus half and y is equal to n pi plus half. So going with the same way as I give here, as I told you here, n has to be 0 only. Otherwise, both will become either positive or negative, that we have already taken care of. So n is equal to 0 will give us x is equal to minus half and y is equal to half. So you can see these are the two solutions, either half minus half or minus half comma half. So there are two solutions. They are asking the number of pair x comma y. So let me write the answer separately here. Half comma minus half is 1. I should not write like this. They are asking ordered pair. So small bracket I will be using, or it will be minus half comma half. Now I was talking about another method using graph. So dear all, this mod x plus mod y is equal to 1 is one very standard graph of a square, or I should say this represents one very standard graph that is a square on xy plane. You can see in the first quadrant when x and y both are positive, this side will become x plus y is equal to 1, and you can see its x-intercept is 1, y-intercept is 1. So 0, 1 and 1, 0. In the second quadrant, where x is negative and y is positive, this equation is given by minus x plus y equal to 1. Similar to this, here it is minus x minus y equal to 1, and here it is minus plus x minus y equal to 1. If we draw all these four lines, we get this square, and taking into consideration that this graph x plus y is equal to x plus y equal to 1 is valid only in first quadrant. Similarly, this portion is valid in second quadrant, this portion is valid in third, and this in fourth quadrant. Okay, now as I did in our previous slide, that x plus y will be equal to even multiple of pi. Okay, so here this will be equal to 0, 2 pi and so on, or minus 2 pi, minus 4 pi and so on, depending upon what value of n we are taking. Now, if I draw the graph of x plus y equal to 0, then it's a line passing through origin and having slope minus 1. So it will be like this, and here it will be intersecting this square at these 2 points. But if we draw x plus y is equal to 2 pi, then x-intercept will be 2 pi and y-intercept will also be 2 pi. So if we join these 2 points, you can see this x plus y is equal to 2 pi line will be lying here, and it is above, it is away from this square. So there is no point of intersection for this x plus y is equal to 2 pi with this square. Similar to this, when x plus y is equal to minus 2 pi, we will be getting line like this. So this is also not intersecting this square anywhere. Similar to this, if we take 4 pi here or minus 4 pi here, then also we will be getting parallel straight line to x plus y is equal to 2 pi, and that will be even farther from this square. So the only possible solution is or are when this x plus y equal to 0 is intersecting either this minus x plus y is equal to 1, and if we solve this minus x plus y equal to 1 with x plus y equal to 0, we get x is equal to minus half and y is equal to half. You can check. So this is the point minus half comma half. Similar to this, there will be another point in the fourth quadrant where x is half, y is minus half. So these are the two solutions for this question. Okay, so this completes the solution of this question. I think this question was easy. This graph is very standard. Most of the student knows it. If you do not know, please remember it. It will be useful in your JEE Mains, JEE Advanced, ISI, CMI, everywhere. Okay, now coming to the next question, that is question number 2. It says, suppose that PQ and RS are two chords of a circle intersecting at a point O. Okay, and it is given that PO is 3, SO is 4. Moreover, the area of the triangle POR is 7. This area is 7. Let me put it into the circle. So, and we have to find the area of the triangle SQOS. This area we have to find. So, dear all, let me call this OR length as A and this OQ length as B. Now, there is one very immediate result that should come into our mind, is that using the power of O point, power of point O with respect to this circle, this product of lengths about O, that means 4 into A and 3 into B, they should be equal. So that is one relation that we should be getting directly after looking at this diagram. Although there is another method of getting the same thing. You can see this QR will be subtending same angle at P as that on S. Whereas at O, these two are vertically opposite angles, so they will also be equal, and hence this remaining angle at Q and R will also be equal. Okay, in fact this can be seen otherwise also, that this arc SP subtending same angle at R and Q. So you can see from this, these two triangles. So these two triangles, which two triangles? POR is similar to triangle SOQ. Okay, so from this, if you compare the sides, although it is already done, it is not required. This side, corresponding sides of the two triangles are 4 and 3, opposite to these angle represented by 3 stripes, and that will be equal to B upon A. These are two sides opposite to this angle given by single stripe. So from this also you can check, we are getting same thing, 4A is equal to 3B. Now, to do this question, the easiest method is, because these two triangles are similar, hence the area of these two triangles, that is triangle QOS or SOQ, upon area of triangle POR, I think this is POR or POR, yeah. That should be equal to the ratio of their corresponding sides square, isn't it? Because for this triangle, this 4 is the corresponding side, which is there 3 in this another triangle. Now we have to find this area, let me call this as A, and we are given this area of triangle POR as 7. So here it becomes 16 upon 9. If we simplify it, we get 16 into 7 is, I think, 112 upon 9. So this is the answer for this question. One very easy question, I will say. Even though you do not know this property, although I will expect everybody to know it, still you can do it by similarity. This property is one very obvious property that we do in our 10th grade. So from there you can do this question easily. Okay, now coming to next question, question number 3. Here we are given that f R to R be continuous functions such that x belongs to R for all t greater than or equal to 0, fx is equal to f of e power t into x. We have to prove that f is a constant function. So dear all, before going into the actual solution, let me do some discussion. Suppose we have some x1 and x2, both positive. Okay, then definitely we can find x1 upon x2 equal to e power t for some t greater than or equal to 0. Let us assume that x1 is greater than x2. Or you may write like this also, x1 greater than or equal to x2 greater than 0. Okay, in that case we will be getting some t, so that x1 upon x2 will be equal to e power t. See, this t is independent from this x, so we may take like this. So if that is so, then x1 will be equal to x2 e power t. Hence, the value at these two numbers, that is f of x1, should be equal to f of x2 e power t, and x2 e power t is also equal to f of x2 from this given relation. So what we have proved, though x1, x2 may be different, but the values at x1 and at x2 are same. So it looks like a constant function. But how do we prove for when they are negative, or one negative, one positive? Okay, I think if both are negative, then also we can do it. But to prove it that it will be same for one negative, one positive, let us do some manipulation. Let us take e power t into x as y. Okay, then this x will become equal to y into e power minus t. Okay, so this given relation can be written as f of y is equal to f of y into e power minus t. Now, if I take this t approaching towards infinity, okay, and y is positive, then can we say that this f of y will be equal to this f of 0 plus? Because if t is approaching to infinity, and for every y we can take t to be infinitely large, so that this product approaches to 0, but it will still be 0 plus. Okay, so this fy will be f0 plus, and because we are given this function is continuous, so f0 plus will also be equal to f0. Similar to this discussion, if we take t approaches to infinity and y less than 0, so when y is less than 0, this fy will become equal to f of 0 negative, because as t approaches to infinity and y negative, this e power minus t will approach towards 0 plus, and y being negative, this product will be 0 minus. And because again this function is continuous, so I can call this as f0. So what I have proved, that whether y is greater than 0 or y is less than 0, or even you can take equal to 0 also, we have proved that f of y is equal to f of 0. F of 0. That means this function is a constant function. So this completes the solution of this question. This question could be little tricky, but again, going by the questions which are asked in ISI, I will still say this question was not that difficult. Okay, you can say average or average plus, but not difficult. Now coming to question number 4, it says let f 0 comma infinity to r be a continuous function such that for all x belongs to 0 comma infinity, f of 2x is equal to fx. Show that the function g defined by the equation gx is equal to integral x to 2x ft dt upon t for x greater than 0 is a constant function. Now I have multiple methods for this question. Let me do one by one. My first method is differentiation by Newton-Leibniz method. Dear all, please understand, f is a continuous function and ft upon t will also be continuous for x greater than 0. So integral of that ft upon t will be a differentiable thing. So we can do the differentiation of this using Newton-Leibniz formula. So g dash x will be that differentiation of the upper limit first, that is 2, then putting this 2x in place of t, so f of 2x upon 2x here, then minus differentiation of lower limit, that is 1, then putting x in place of t, so it will be fx upon x. Now this 2 will cancel this 2, f of 2x is equal to fx, hence this is equal to 0, so this is a constant, so this gx is constant function. Very easy method, isn't it? So what can be other method? Please see the second method. My second method is that let us try to find what will be my g of x plus h. Okay, so this will be, we will be writing x plus h here, 2 times x plus 2 times h here, and ft upon t into dt. I can break the limits like this, x plus h to x ft upon t dt plus x to 2x ft upon t dt, and in the end this 2x to 2x plus 2h ft upon t dt. Here also it is dt. Okay. Now I will be doing some substitution in this last integral. I will put t is equal to, I will be putting 2t is equal to u actually, or let me just think, yeah, it will not be like this, it will be t is equal to 2u. T is equal to 2u. If I do this substitution, my first integral is not changed at all, x plus h to h, or let me do one thing, let me change the limits and put one minus sign outside. So minus x to x plus h ft upon t dt plus this is nothing but gx only, and this integral after doing this substitution, when t is 2x u will become x, when t is 2x plus 2h it will become x plus h. Here ft will be f2u and t will be 2u here, and dt will be 2du. Okay, so 2 is cancelled, and now you can check these two integrals, first one and this one, they are exactly same, just a difference of that variable of integration t, so that doesn't matter. So these two will be cancelled, and you can check that we have proved that g of x plus h is equal to gx. G of x plus h is equal to g of h, and it is for any arbitrary value of h. So this is a constant function. So you can see there are two questions continuously which are based on constant functions. Okay, I was talking about another method. Let me tell you this method 3 also. Actually, this is just the proof of Newton-Leibniz method. We can assume that integration of ft upon t dt will be some capital Ft. Okay, so my gx will become equal to, after putting the limits, capital F2x minus capital Fx. Now if you do the differentiation, this g dash x, it will be capital F dash, and capital F dash means it will be small f upon t. Let me first write capital F of 2x into 2 here and minus f dash x here. Now this 2 times capital F dash 2x will be small f 2x upon 2x minus f dash will be small fx upon x. So this 2 gets cancelled, and if you see, because f2x is equal to fx, so here we will be getting a 0. Okay, so this is how this question can be done. These are the 3 methods. If you can find some more, let me know. Okay. Now coming to question 5, which says f r to r be a differentiable function such that its derivative f dash is a continuous function. Moreover, assume that for all x belongs to r, f dash x mod is between 0 to half. Define a sequence of real numbers an given by a1 is equal to 1, an plus 1 is equal to f of an for all n belongs to capital N. Prove that there exists a positive real number m such that for all n belongs to capital N, mod an is less than or equal to m. Now to do this question, first of all we should understand that we have to prove that whatever bigger value of n we take, an is going to be finite. If we are able to do that, then I think we are done. So in the sense, what I am going to prove, that if this sequence is increasing, in that case the last number, that is when n approaching to infinity, this mod of an will be a finite number, and if that is so, then we may find a number m which will be satisfying this relation. Okay, now let me tell you, this a1 is equal to 1, which is already finite. So for a1 we can definitely write there will be some m for which mod a1 will be less than or equal to m. But we have to prove that there will be single value m, there exists a positive real number m that will not only be satisfying this mod a1, but it will be satisfying all values of an. Now to do this thing, let us see how we can do it. I'll be using Lagrange's mean value theorem. First of all, please understand that an minus an minus 1 mod, it can be written as f of an minus 1 minus f of an minus 2 because of this relation. Okay, now because this function is differentiable and f dash is continuous function, so this difference of mod f an minus 1 minus an minus 2 using LMVT, let me use LMVT in this corner here, LMVT once again, let me write it, this f of an minus 1 minus f of an minus 2 divided by an minus 1 minus an minus 2 will be equal to some f dash c, where this c lies between an minus 1 to an minus 2, because this function is differentiable and f dash is continuous. Okay, so let me put a mod here. Let me put a mod here. So this will be less than or equal to half. So using this, we can write this f of an minus 1 minus f of an minus 2 will be less than or equal to 1 by 2 mod of an minus 1 minus an minus 2. So if we reduce this suffix by 1 each, we are getting this relation. Now using the same thing, once again, I will be writing 1 upon 2 power 2 mod of an minus 2 minus an minus 3 and so on. And in the end, it will be 1 upon 2 power n minus 2 mod of a2 minus a1. Every time the power of 2 is increasing in this denominator and this suffix is decreasing by 1. So you can see the sum of this power and this suffix is always n. So here also it should be n. Now I will be doing one thing here, that I will be writing an minus a1 inside mod, and I will write this as mod of an minus 1 plus an minus 1 minus an minus 2 and so on plus a2 minus a1. Now using the inequation of modulus, we can write this as less than or equal to an minus 1 plus an minus 1 plus an minus 2 and so on. In the end it is a2 minus a1. Okay, so what we have obtained for mod an minus a1 as, if I use these relations also, like mod of an minus 1 is less than or equal to 1 upon 2 power n minus 2 into mod of a2 minus a1, then this next one is 1 next to this mod, so here the power of 2 will be 1 lesser and it will be a2 minus a1 once again. Similar to this we will keep writing, and the last term is a2 minus a1. So you can check, we can take a2 minus a1 common, and let me reverse the numbers that we got in common. So 1 plus 1 by 2 and so on, and last one would be 2 power n minus 2. Okay, now even if we take limit n approaches to infinity, you can check an minus a1 will be less than, because the limit of this thing will be 2, this will become infinite GP when n approaches to infinity, and sum of this will be 2. So we can write this as a2 minus a1 into 2. This 2 will be just the limiting case. For any finite value of n, it will never become equal to 2. That is why I have used this less than sign. Now a2 has to be finite. Why a2 is finite, please understand. Let me just explain it here. Let me use this space here. This a2 is actually equal to f of a1. Okay, and f of a1 is f1, because a1 is 1 and 1 is in the domain of this function, so its value has to be some well-defined finite value. So this will be a finite number. So a2 is finite, a1 is 1, so that is also finite. So we can say that even if this limit n approaches to infinity, or whatever n we take, okay, whatever n we take, we can say that, let me remove this thing, we can say that for any n approaches to, for any n belongs to infinity, including 1, 2, 3 and so on, or taking till infinity, this mod of an minus a1 is going to be less than 2 times mod of a2 minus a1. And because this is finite and a1 is finite, this difference is less than these finite values. Okay, you may write like this also. Let us call this finite value as k here. Let us take this finite value as k here. We will be writing an minus a1 to be less than k and greater than minus k. So this an will be less than k plus a1, it will be greater than minus k plus a1. But in both sides, whether k plus a1 or minus k plus a1, we can say that this an is finite. Okay, so it depending upon what the value of k is. A1 is already 1. I think I could have written a1 as 1 here. So depending upon what is the value of this f1, this an is going to be between these two numbers. So an will be finite, hence we can write this. So this completes my solution of this question. Okay, this question I will say little tricky, because to prove it completely to the satisfaction of the examiner, it could have been a difficult task in the time frame of the exam. Otherwise, again, if you take ample amount of time, this question can be average, not difficult. Okay, Coming to the next question, that is 6. It says A greater than or equal to B greater than or equal to C greater than 0 be real numbers such that for all n belongs to n, there exist triangles of side lengths A power n, B power n, C power n. Prove that triangles are isosceles. Isosceles means I have to prove that two of the side lengths will be equal. Maybe the bigger two or the lesser two. So that is what we need to prove. Okay. Now please understand, because they are saying there exists triangle of side length A and B and C and for all n. So for n is equal to 1 also, we should have a triangle, and we are given A greater than or equal to B greater than or equal to C greater than 0. So here this A being largest side, but because A, B, C are the sides of triangle, A will be less than B plus C. Okay, so here we can write this as 1 less than B by A plus C by A. Okay, now let us assume for the time being, if what we have to prove that triangles are isosceles. If the triangles are not isosceles, then A is not equal to B is not equal to C. In fact, there will be a strict inequation A greater than B greater than C. Okay, in this case, using this A less than B by A plus C by A, but because A power n, B power n, C power n are also forming triangle, so also we should be having this 1 to be less than B upon A power n plus C upon A power n. But if there is a strict inequation, if this A greater than B greater than C, then this B upon A and C upon A both will be less than 1, and as n approaches to infinity, this B upon A whole power n will be tending to 0 and C upon A whole power n will be tending towards 0. So this 1 less than B by A whole power n plus C by A whole power n is not possible. Is not possible for large values of n. And why this impossible thing is happening? Because we assumed that triangles are not isosceles, that is all A, B, C are different. So from this contradiction we can say, so triangle has to be isosceles. So triangles has to be isosceles. In fact, in this question, what we can think of, what will be the possibilities? I think this is some extra thing we can discuss here, whether A will be equal to B and less than C, or we will be having A greater than B and B is equal to C. What is the possibility? I think this is the possibility, because in this case as A equal to B, and from this relation 1 less than B by A raised to the power n plus C by A raised to the power n will be true always, because this term itself is 1, and whatever C upon A is, we will be getting this inequation to be right. But if you take A greater than B equal to C, in that case once again we will be having 1 less than B by A power n, which is less than 1 because A is bigger number, and similar to C by A power n, this will not be true, this will not be true after certain value of n. So for large n, this will not be true. This will not be true. So not only this will be isosceles triangle, the only possibility here is that two large values A and B are equal and the smaller value is C. Okay, so this question again I will rate as average only, not very difficult, because it is very much obvious that if they are saying triangle is formed, then this inequation we have to take in the beginning itself, and then using for any n and using this limit is also obvious thing that will come into our mind. So this question I will rate as an average only. Now coming to next question, that is question number 7. Here we are given that ABC belongs to n be such that a square plus b square is equal to c square and c minus b is equal to 1. And we have to prove that a is odd, b is divisible by 4 and a power b plus b power a is divisible by c. Okay, now to do this question, I think first part is very easy. How it is, let us see that a square can be written as c square minus b square. And c square minus b square, I can use that factors c minus b, c plus b. C minus b is 1. Okay, and then I put c is equal to b plus 1. So b plus 1 plus b. So this a square is actually coming out to be 2b plus 1. Let me call this as equation number 1 here. Because ABC all are natural number, so that means a square is odd. And a square can be odd only if a is odd, because a is integer. So a square is odd only if a is odd. You cannot have square of any even number to be odd. So a is odd. So that first part is, I think, proved. Now we know that if a is odd number, then a square has to be 8k plus 1. It can be proved in the exam. If you think it is not obvious or examiner may deduct your marks, you can prove it this method, that 2n plus 1 is the general form of any odd number. So its square we can write as 4n square plus 4n plus 1. Okay, so this becomes taking 4n common, n plus 1 here plus 1. N and n plus 1 being two consecutive integers, so at least one of them or one of them, exactly one of them has to be even. So this will give you 2 common from it, so it becomes 8k plus 1. So this is how we prove that square of any odd number is of the form 8k plus 1. Now a square will be 8k plus 1 and it is also 2b plus 1. So from this, if we compare, we get b to be 4k types. Okay, so this second part is also done. Now coming to this third part. Third part is also not very difficult but little tricky. Please see how we can do it. They are saying a power b. So what is a power b? A is odd number and b is multiple of 4k. In fact, a power b can be written as a square power 2k. A square power 2k, because b is 4k and a square is 2b plus 1, which I can write as, please see, 2b plus 1 power 2k, and because b is c minus 1, so if I write this in terms of c, it will be 2c minus 1 whole power 2k. Okay, so what you can see, this a power b is actually 2c minus 1 power 2k. So if you expand it binomially, okay, or otherwise, you can see this will be c into some integer plus in the end there will be 1. Yes or no? We can use concept of congruence modulo also. This is even power, so last term will come with plus sign. Okay, now what is b power a? B is actually c minus 1 raised to the power a, where a is odd number. And if it is odd number, using binomial theorem, once again this will be c into some integer and minus 1 here. We can use this by concept of congruence modulo also. So you can check, if we add these two, a power b plus b power a, this will be that 1 will be getting cancelled and we get c into some other integer. So that means this a power b plus b power a will be divisible by c. So all the 3 parts are done. Okay. Now coming to the last question of this paper, that is question number 8. It says, let n greater than or equal to 3, a is equal to ij between 1 and n be an n into n matrix such that aij belongs to 1 comma minus 1 for all ij between 1 to n. Suppose that a ki is equal to 1 for all k between 1 to n, and this sigma k is equal to 1 to n, a ki into a kj is equal to 0 for all I not equal to j. Okay, we have to prove that n is a multiple of 4. So dear all, first of all, please understand this is a matrix of order n into n. And we are given that a k1 is equal to 1 for all k between 1 to n. That means all the entries of first column are 1, 1 and 1, 1, 1 and so on 1. Okay, now if I use this summation here, in which if I put k is equal to 1, not k, if I put I equal to 1 actually, because they have said for all I, just the condition is I not equal to j. So if I put I is equal to 1, then this ak1 will become 1. So this is just the summation of ak j is equal to 0, which means and here k will be from 1 to n. Okay, so what does that mean? That for any column other than first, second column, third column, my entries should be such that sum is equal to 0. Let me write it like this: 1j plus a 2j and so on plus a nj. That will be equal to 0, and that will be 0 only if some of the entries are 1 and some of the entries are minus 1. In fact, half of the entries should be plus 1, half of the entry should be minus 1. So first of all, we are able to prove that number of entries here will be actually even in number. So we can say, let us say that m are ones and m are minus ones in these in this n entries, where n will be equal to 2m. Okay, so this will be true for j is equal to 2 also. So my second column, I can say it will be having m number of ones and m number of minus ones. Okay, now this relation is valid for all I not equal to j. So if we take, let us say I is equal to 2 now and j is equal to, let us say, 3. That is multiplying corresponding elements of second column with the third column. Then also it should be becoming 0. Now here also we have proved that for in every column we will be having exactly m number of ones and m number of minus ones. So let us say they will be like this. So half number of plus ones, half number of minus ones in this second column also. But in order this product to become equal to 0, what we need to have, we will be multiplying either 1 with minus 1, or we will be multiplying minus 1 with 1, or we will be multiplying 1 with 1 or minus 1 with minus 1. These are the possibilities. Okay, so this is my second column and this is my third column. Now number of ones are m in number and they are at 2 places. So suppose these number of ones are r in number. Okay, so these number of ones will be m minus r in number. Okay, so this product, if it is happening at r times, this 1 into 1 will be happening m minus r times. And once again in the third column, this minus 1, if it is appearing r times here, so this minus 1 here will be appearing m minus r times. So this product will be happening m minus r times. So once again, this minus 1, if it is appearing m minus r times here, so this minus 1 will be appearing r times here. Now this first product, as you know, it will be minus 1. Second product will also be minus 1. This third product will be plus 1 and last product will also be plus 1. So if we add minus 1 r times, it will give me minus r. This minus 1 r times will give us minus r, and here m minus r and once again m minus r. And this should be equal to 0. So what we are getting here, we are getting 2m is equal to 4r. 2m is equal to 4r. So what we have obtained, actually, we have obtained that this n will be actually equal to 4r, and that is what we have to prove. I think this last part was tricky. Everything was fine. This last part was tricky. So I will rate this question as little difficult. Not very difficult, but little difficult. So this is how this question will be done. So this completes the solutioning of this ISI Part B. Dear all, if you are preparing for JEE Advanced, then this Vedantu Eklavya is one good thing, one very important thing for you to know. If you are not aware, please Google it. We are preparing students for JEE Advanced in online mode, and that is one very important thing. We have produced very good results in last 2-3 years, actually not 2 years, actually 3 years, 4 years. In fact, you can check on the Google. You can go through this website of Vedantu Eklavya also. There you will find everything. And I am sharing here this link for the notice board of Topper Pod, where I have put all the information, where we have put all the information regarding new batches coming up or new things coming up in these batches. This is the QR code for the same. Okay, so please follow this notice board. It can be useful thing for you. If you are going to write JEE Advanced in 2023, this is the link and this is the QR code of that Telegram channel where we are putting all important informations for you. So please follow it. You will come to know all important things, relevant things for you. Similarly, for 2024 aspirant students, these are the links and QR code for that Telegram channel. Dear all, this is the V-Impact YouTube channel where we are putting solutions of JEE Advanced, KVPY, ISI and CMI. So to get new kind of solutions or alternate methods of these questions, please follow this channel. This is the link and this is the QR code for the same. So that is all for today. Thank you so much. Next week, I'll be coming up with another paper of, this time I'll take CMI paper. Okay, so stay tuned and take care. Bye.